Yes. So rightly, I formally welcome each and every participant to be with us for this session. And let me share, let me introduce our uh, experts for this morning session and session two. And this theme of these two sessions will be IR based in data integration techniques or maybe fundamental concepts related to that. So I formally welcome Professor Mukesh Mohania sir for these two sessions with us. And let me introduce or share the citations or the milestones of our experts. Like Professor Mukesh Mohania sir is currently working as a professor at computer science and engineering department, and he's also looking into the dean office of IRD at IIIT Delhi. He has a 20 year of experience in IT architect and innovation, and has held senior technical and business leadership roles in IBM research and development labs in India, including most recently as a distinguished engineer and director of AI, which is a coming field, I mean, which is picking up now, and blockchain and cognitive analytics at IBM Research Australia. So I think because of this thing only, Sir is still, I mean, connecting with us from Australia. And Professor Mukesh is having an innovation center on information integration on structured as well as unstructured data, master data management, AI for database and entity analytics, big data analytics, atomic computing, blockchain data management, and developing complex system and applications in these areas. So over the course of his career, he has had a lot of successful project completion that produced technology and different products in basically across the industry are being used, as well as the influential and frequently cited technical works and patents. So that is something very basically been attracting as beginners like us. So he holds 60 plus granted patents and published 100 plus technical papers in reputed international conferences, has widely participated in industry forums. So I have been, I mean, some experiences of Professor Mukesh talk. I mean, most recently during the last BDA itself, BDA 2019. For these accomplishment, IBM recognized him as a IBM Distinguished Engineer in year 2013, Master Inventor in year 2010, member of IBM Academy of Technology in year 2011, Best of IBM in year of 2013, and he has received several IBM corporate and research level awards like Excellence in People Management, uh, Outstanding Innovation Awards, Technical Accomplishment Awards for the client's business impact, Leadership by Doing, and a lot many. So this is something which we cherish as a, I mean, we have a guest, we have expert from these kind of, I mean, achievement with these kind of achievements. So along with it, sir is having, I mean, various I mean, well-known positions like ACM Distinguished Scientist from 2011 onwards, VLDB Conference Organizing Chair in year 2016, ACM India Vice President during 2015 to 17, ACM Distinguished Service Award Committee Chair during 2017 to 2018, Adjunct Professor and Industrial R&D Board at various top universities and institutions in India and Australia, and many more. So most recently, he has received IEEE Meritorious Service Award and ACM Outstanding Service Award. So I mean, it is highly privileged. We are highly privileged that we have with us Professor Mukesh Mohania sir. So we will be listening each and every detail carefully, and we will try to utilize this opportunity to learn most of the concepts, most of the technology details, sir. So over to you, sir. Now, thank you, sir.
Okay. Thank you, Professor Vikas. Um, and thanks once again, Vikasji, for inviting me on a very,
Yes,
very interesting topic and very
yes, sir.
pointed topic and very highly relevant in today's scenario.
Right, sir.
And this is what basically I'm going to spend the first 1.5 hours of first session to motivate you with different scenarios where we need the entity extraction or the information retrieval based information integration. So I would like to really keep this session interactive. So if you have any questions, Either you can wait. I will make sure basically I'll finish 15 minutes before so that we can keep 15 minutes for the discussion. Or if you would like to basically ask the questions in between, you can ask the questions. Since I'm on the presentation mode and it is in the full view, I cannot see the chat room. I cannot see basically you raising your hands, right? So you just speak up on that, right? So before I start, let me also welcome you all to this FDP. And as I said, Vikasji has done a wonderful job for organizing this very thoughtful and timely topic, right, on this FDP. Yeah.
Yeah. So let me, sir, interrupt in this. Actually, the name was Vikram actually.
Yeah. So sorry,
Yeah,
Vikram.
it's okay, sir. It's okay. Yeah.
Yeah. Yeah. Okay. So let me first go why information integration is important. So as Vikramji basically gave a brief bio about me, and you see that I have spent most of my career in industry. So I'll give you more industry flavor, right? Real applications on that, right? And less theory on that, right? So in any organization, in a large organization, even a medium organization, you have number of information sources. You have some of the sources could be a relational databases, that is a structured database. Some of the sources could be unstructured information, where the information is stored in a files, or it could be basically any other modeling, data modeling techniques. And some of the information may be a semi-unstructured, which is like stored in like HTML or the XML pages, right? So the IT budget that is allocated to the CIO, the 40%, roughly 40% of the IT budget is spent on the task related to the information integration, which includes identifying the data, which includes basically doing the data cleansing, that is the data curation. That also includes basically how my data can be integrated from various data sources to show the single truth of the data, or to show the 360 degree of the business object, which is an entity, right? And I will be using the word entity right throughout this presentation. An entity is like something in the organization where basically you organize the information along that one. So entity, like my client is an entity, my product is an entity, my different assets could be an entity, right? So these are the entities of one, right? So 40% of the IT budget really spent on the activities related to the data integration. And these activities includes, as I said, the data acquisition, includes the data cleansing, includes the data creating the data linkages, and before linkages, transforming the data or data wrangling, right? And then linking the informations through various resources, so that these information is searchable, and they are searchable in a federated manner, right? So that's why, and that is why the information integration is the core challenging problem in all the organizations. So if you look at in the organization, how my information is being flowed, right, in the organization. So here, yeah. So you have various information resources, right? They are getting the data into the various kind of content repositories or the data repositories. So the one big task is basically how to manage the data, right? And these data could be my transactional information. These data could be my operational information. These data could be my, my any other analytical kind of information, right? So all that information is being stored in various repositories. Either that could be the content management system, or that could be streaming data, or that could be a relational databases over here, right? Now then this information flows to my, either to the information integration we call the master data, where the master data has the single view of all the entities. So let's say if a client information is in my various repository, and that there is a same client. So in one, let's say you have a Vikram Singh, in another one you have a Professor Vikram Singh, in another one you have a Prof Vikram Kumar Singh, right? You have a different variants of the same entity. Then how we can unify all this information and make it a single truth that it is, let's say, Vikram Kumar Singh. So that, and then we map that information to the source data. And that is what is the master data is. So master data tells you the single truth of each entity in the organization. When the master data comes over here, then you can bring the highly summarized and aggregated information into the warehouse, where the data is materialized. Is typically it is organized in a subject oriented manner. So like this is a sales data, this is a manufacturing data, this is a procurement data, this is a client information data, and so on, right? So we organize the data into a subject oriented fashion, and this is typically the information is gathered on in a historical basis, right? So it's a historical, highly summarized, aggregated information over here. And this is what basically we need the data integration. So you have a data points over here, various data in silos. You bring that information, curate that information. Curation, as I said, basically includes not only the data cleaning, but also understanding the semantics of the data. Why, like, as I said, Vikram Singh in one record and Vikram Kumar Singh in another record is maybe VK Singh. Should we merge all these three into one entity or not? So there has to be a semantic relatedness with respect to my other contextual information associated with that entity. Then only we can merge that. If there could be that VK Singh and Vikram Kumar Singh, these three different entities could be a different entity. These could be three different individuals, right? So that is what basically the data integration task comes in: getting the data, cleaning that information, transforming that information, changing the format, and then basically creating the linkages, right? Or creating the correlations between the data, and then summarize that information, dumping that information into the warehouse, where the data is typically modeled in a relational data model, but then you have on top of it, you have a online analytical processing which views that data as a multidimensional data, right? Then once the data has been integrated and summarized, it flows to my analytical tools, where you have content analytics, you have a big data, you have a different cubes or stream data analysis, and all that things basically where my business applications are consuming this data through a set of libraries with you over here. And here all my machine learning based libraries, all my data understanding libraries, they all basically store as a part of these tools, of analytical tools, right? So this is the typical flow of information from source identifications to the data analysis. And all this information around that, you have a complete information governance. And reason for having a information governance here is so that basically one can define who can use the data, when they can use data, what they can use data, for which purpose they can use the data. So we define basically the complete information governance and the life cycle of that data in these three stages, right? The data is of high quality, highly trusted, relevant, and the governed. So this is the complete how to master the information across the information supply chain, right? So now, as you see basically that there are two types of information. One is the structured data, which you typically store that in a relational database. So like, for example, my student. So you have a, or let's say employee, right? So we have a employee number, employee name, date of birth, in which department that employee works in, and blah, blah, blah. Right? So we have this information, same information for employee 1, for employee 2, for employee 3, for employee 4. So it's very much structured information, right? So that is what is basically is my traditional way. This is called the system of records. So each employee in that table is called a record or tuple, right? So my this relational database systems, so structured information systems, whether they are ERP systems or whether they could be my online transactions processing or the operational data stores or transactional information, all of them are very structured, right? And they are called the system of records, right? On the other hand, and this is my, on the other hand, the spectrum of the other hand is my unstructured information. Unstructured information is generated typically when you engage with the system. So when you engage with the systems, you are basically writing an email, right? When there is a system throws some error, you create basically some kind of log, right? You tweet the information, you upload that information, so there is a social media, the information, right? Which basically does not have any structure in that data. So that is basically the system of records, right? And this is basically is the unstructured information. The value lies basically, and this is completely what AI and machine learning are doing, is how we can learn or how we can derive the knowledge from the unstructured information with the contextually given information into the structured data. So this what is this here is the intersection of system of records and the system of engagement over here, right? And this is what basically people are realizing, how to connect the dots from structured data to unstructured data. And we will see several examples, and this is what I'm going to focus mostly basically or in this intersection part, that the entities which are defined in the structured data. So let's say again the entity is Vikram Singh, is an entity, works on the NIT Kurukshetra, that is an organization, that is also entity. And then there is a document, there is a research paper, basically that mentions the Vikram Singh, Sanjay Jain, and other authors basic there, and the affiliation is given NIT Kurukshetra or National Institute of Technology Kurukshetra. So how to extract the entities from in the unstructured data, right, and use those entity to correlate that with the structured data. Then we can say, hey, this Vikram Singh, employee number 1234 in NIT Kurukshetra, is the same person basically who has published this paper where the affiliation is National Institute of Technology Kurukshetra, right? So based on the entity extraction from the unstructured information to correlate that with the structured data for creating this data integration layer or data linkages layer is the focus basically of these talks, right? So we will discuss. So this is the outline. So the three topics mainly. The first topic is we will discuss the architectures of information integration. And typically there are the vendors, whether it's IBM or Oracle or any, they are basically selling the information integration related product in these two, based on these two architectures, virtualization and materialization. So we will look at that. Then we will look at basically that there are many other types of information integration scenarios which basically have dealt either in the master data management or basically creating a layer on top of the information integration tools. And then they feed back to the, again on these tools to integrate the information to solve those scenarios. In order to basically build the applications, information integration application, what are the key challenges in the technology from a research perspective, right? So that is one. Then we will discuss is, as I said, our focus in this is that how we can apply the machine learning algorithms to find it out that, hey, this document lying in my email system or my file system is related to this particular entity which is stored in my relational databases. So very naive example is basically when you write an email to give a feedback, or let's say to write a complaint or to ask about your product that you already have, when you send an email and then the system automatically identifies, hey, this email which has come is registered in my relational databases against the customer, and then I say, hey, Bikram at IIIT, Bikram at basically NIT Kurukshetra or whatever co.in is same, basically the same person is there, and that's why they correlate these emails with the structured entity over there. Right? So that is what we are going to discuss, that how to extract the entities, the various approaches, dictionary based, rule based, and learning based. And we will take one example for each of them. And for the learning based, we will look at both supervised algorithms as well as the unsupervised algorithm. Once you have extracted the entities, then we are creating this match or linkages. So email comes in, we extract the email, the ID, and if that email ID exists, I go and look at basically in the another database. If that email ID already exists there, then we create this linkages, right? But in a real scenario, given two records, so one company is acquiring another company, right? Now they want to merge these two databases, then they have to do the entity matching, right? Or data record matching. So we will again discuss the rule-based and the learning-based methods for performing these entity linkages or data integration. Okay. So by now you have some idea what is an information integration. So the information integration is a middleware software which lets the application access the data as though were there in the single database. So you give a query. So let's say basically on the underneath in the databases, you have your bank account in a, let's say in a bank, basically you have your bank account, then you have a mutual funds, then you have a stocks and so on. And each of this information is in different data sources. Today, all the banks, they provide you the single view. When you log in, they can tell you basically, okay, this is your portfolio value, this is the mutual fund, this is the stocks, this is the one. So they provide you the single view of all the data, all the investment related to you. And this is an example of data integration. But what basically this this middleware does basically that when you access that information without knowing, you basically fetches the information from various data sources and provides you the single view of that information, right? So that is what the information integration is. One of the biggest challenge that comes into the uh, information integration, other than the technical challenges, right? There are many technical challenges related to identify which data I need to fetch in. If the same information is scattered on 20 different places, one is older than the another one, they have a different view, right? Or different variants of that information, which one I should need to choose that, right? Or how to clean that information. Other than the technical issues, one of the social challenge is that how to convince the data owner to share the data for the applications that the business is designing. And this is a really big problem, because every data owner or every data source has the data administrator or data owner, right? So we, like for example, in the bank, as I said, if you have a credit card, you have a account information, you have a mutual fund, you have a this. Each of these one is a different part of the business. They are in silos. So convincing them that, hey, we need to basically integrate the information for every entity, every client, so that the client can have a single view of the information, right? So convincing the business owners is not that easy. Well, there are some legal issues, there are some ethical issues, right? So this is one of the social challenging problem. So now let's look at the integration. So as I said, there are two types of integration. One is called the mediated schema. Mediated schema means here is you define the schema over here. That is just a definition. So the definition over here is that we want to get, let's say, this is your credit card information, this is your bank information, bank account information, right? Savings bank, and this is your mutual fund information, this is your personal home loan information, and so on. So here you say that when anyone comes through application access that, then for that application ID, you can say basically that single view or total investment is get the data from here for the same customer, get the data from here, get the data. So here you just keep the definition over here, as and when the client comes in, that query basically written over here on the mediated schema, then the query is decomposed into subqueries, and each subquery relevant to the source goes over here, executes over here, and get the answer, and the answer is get integrated over here, right? That is what is the mediated schema approach or the virtualization approach. The other approach is that for certain applications, right, you just get the view over here, compute the view, store the view, the result of that view over here in this schema here, right? So when the query comes in, you can answer that query at this level over here. You don't need to go every time to the data source level to execute each of the subquery. So the advantage in the warehouse approach is it is very fast from a performance point of view, because you are answering the query, you are executing the query in the warehouse itself over here in this, right? You don't need to go over here. But the disadvantage here is that this data may be old, maybe little bit old. It might have been basically your all the transactions values basically as of yesterday, and you might have basically deposited or bid or sold some mutual funds or this or that basically, which may not have reflected over here, right? So that is a disadvantage. In the mediated approach, the performance is very poor. I wouldn't say very poor, is poor as compared to the warehouse, because every query has to go over here, gets executed, and then the results comes back over here. Then you basically change the format, make sure basically that all the results are integrated, right? And then you give back to the user, right? But the advantage over here is that since every time the query comes, you are executing the part of the query to the relevant data sources, so then you get basically up-to-date information, right? So depending on basically what kind of application is, you need to choose basically the mediator approach or the warehouse approach, right? So let me go a little bit in detail over here. So this is what I was saying, the data warehousing approach. You have a different data sources, you get that data, integrate and dump the data into the warehouse. You organize that data into some kind of either a multidimensional form or to a relational database form. Then you have a multidimensional or relational online and analytical processing over here, which view this information as if basically this is a multidimensional data, and you then run various applications on top of it there, right? This is a warehouse approach. Whereas in the mediator approach is the query is given over here, right? That query comes over here, it decomposes that query. Okay, this guy basically identifies, hey, this query, the part of the query should run on the S1, the part of the should run into S2, and the part of run in the S3. So this guy basically decomposes that query into Q1, Q2, Q3, and Q1, Q2, Q3 goes to the respective of the data sources, gets executed locally, get over here, integrated, and the answer is given to the user, right? So it has its own advantage and disadvantage, as I just told you. Okay, so this information integration is a long-standing problem. There has been tons of work in the last 30 years, and the many communities, right? The database community, of course, the AI, the machine learning one, the KDD web, semantic web, right? All these communities have come together and have solved application specific information integration, right? No, because the nature of the data is different, therefore you need to develop or you need to customize the methods which already exist, whether for the data maintenance or for the data cleansing or for the data linkages, right? Because the type of the information is different, so therefore you need a different methods to clean that information, right? So there are a lot of work has been done in this, but it's still the open area, right? And this is my very pet area. Basically, I've been working in this area from last couple of decades. Okay, so how my platform for the information integration really look like? So as I said, in the enterprise, you have various kinds of information sources. Some of them are like running on the mainframe computer, some of them are just files, some of them are in the relational databases, XML, the content page, content management, and so on. So you have various types of information, and these are the technology basically that can be used for this information, right? So now here is, you are given any kind of data, and now we need to access this data and the content both, right? So now there are multiple access paradigms, like search, through search, like in Google, through search basically you can access the information, or you can do the SQL query, you can write the select project join kind of query, select ABC from relation R and S, where this and that, right? You can write those queries and the query can get executed. Or you can write the X query, right, running on the XML database, or you can convert that X query into the SQL or any other things. Or you can directly basically access the content using, like kind of predicate or contains kind of predicate over here, right? So now there are various kind of services available, right? the different, and like you can say find, or you can federate that information, you can transform, you can consolidate, and you can publish it, that information. And this is what is basically is all information. When you relate, federate, how you have correlated the information, how you have federated the information, how you have transformed the information, all that information is stored in my metadata. So the metadata management is very crucial aspect of information integration. Or indeed, for developing any system, we have to basically keep that knowledge, how we have done it, right? So that in future, when new information comes in, we can look at the metadata and then basically perform all the cleaning or transformation or consolidated task based on the metadata, right? And there are several integration design tools offered by different vendors, right? And in all these areas, data federation, transformations, data cleansing, right, and so on. Right? So now let me take to few scenarios, a very really interesting scenarios where we need the information retrieval, right, or entity extraction in order to integrate the information. So as I said, the first and very simple example is to get the single truth of the information. So when a telecom company started in India, they initially basically offering only the landline service. So there is a guy called Rahul K. Sharma, and we have a record of Rahul K. Sharma. Date of birth is this, phone number is this. Now, this company basically started a mobile phone service. Then Rahul basically, I don't know Rahul, but there is one record that is basically says R. Sharma, 55 Froja Link Road, and so on. And similarly, the first satellite TV. So the point basically I'm trying to make it over here is that every business line, and what is a business line? Business line from the landline, business line for the mobile phone, business line for the satellite, business line for the broadband services. Each business line created their own database. Okay? And they are running the business, no problem. Right? You get earlier, not now, basically earlier you were getting two different bills. One is for the landline phone, if you have taken, let's say, from MTNL, and if you have MTNL mobile phone also, Dolphin service also, you get a different phone bill there, two different bills. So now this company, this company or each business line here, has their own CIO. So there was a CIO for landline business, CIO for the mobile phone, CIO for broadband, and so on. So each business line decided their own loyalty program. So the mobile phone guy, basically the CIO decided if a client is paying 500 rupees, spending 500 rupees on the mobile phone, then they were assigning that client as a gold customer. And for gold customer, they have a dedicated line so that when they are dialing it from the phone number, the system can recognize, okay, this is a gold customer, and then that call will diverted to some dedicated people so that they can address their problems, right? And people are very happy, right? They were just calling within a minute or two, basically they are connected, they listen their problems, they solve that problem. Excellent. But same person, he had basically, let's say, the landline one, but landline, his bill, since most of the time he's using the mobile phone, landline phone was just minimal, very minimal, 20, 30, 40 rupees, whatever. And this guy basically here decided, the CIO decided, if a client is paying 250 rupees or more for the landline, then he is a gold customer. So the definition of the gold customer was different from mobile business line to the landline to the broadband to the satellite TV. So this guy, R. Sharma, this guy basically calls, has some problem in the landline. He calls basically a number and then he's on the wait because the system recognized that he's not a gold customer. So they put it on a different queue, right? And this guy really was in the queue waiting for 5 minutes, 7 minutes, 10 minutes. He really got frustrated. And then he basically writes, I want to disconnect my landline number. And also basically, I want to switch my mobile, right? Your company, this, blah, blah, blah. I want to really move it to some other service provider. So then they figured it out. This company figured it out. Hey, the business is losing the customers. And the reason for losing the customer is when the same customer comes from for one business, he's given a fantastic basically service. But when he comes for the another things, he is really highly disappointed. So then these CIOs, they decided that if one client is tagged as a gold customer in one business, let we tag him or her as a gold across all the business lines, irrespective of basically whether that guy is giving a business or not, right? Give the highest tagging based on the business basically he's providing, right? So then to solve this problem, the use case is very, very simple. That is, if Mr. R. Sharma is a gold customer over here in mobile phone, can we find it out R. Sharma in my landline, satellite, broadband, and any other things, right? Is there any R. Sharma with these credentials and tag that person as a gold customer? That is the problem. But this problem is really, really very, very hard problem. And hard, why? Because all the artifacts of that entity. What are the artifacts of the entity? Are the name, a address, a date of birth, and the phone number, right? And there could be, right? Now we need to check whether is R. Sharma is same as the Rahul K. Sharma, is same as the Rahul Kumar Sharma, right, or not, or this phone number, right, is the same over here or not. So we figured it out. Hey, the phone number over here is same over here. The last name is same. The first name is also same. It is very likely the entity matching algorithm that we will discuss in the second talk. It is very likely basically that these two people are the same. So we extract the entity, we match the entity, and then we define the similarity score. So for example, here we define the similarity score based on the two things, based on the phone number and the name. So we can say we give 50% weightage to the name, 50% weightage to the phone number, and if they are matched, right, then they are matched, right? So that's what basically is. So we extract these entities, right, and based on some rule-based ones, right, or we can apply the learning-based machine learning algorithms that we will discuss in the second one. And similarly, basically go over here, and then we figured it out that on what basis basically this links. This links basically based on some identifier over here, 1133107, 1133107, and there are 3 zeros here, there are no zero over here, and therefore basically this is same. So this is same, this is same, therefore basically all of them are the same. And when all of them are the same, basically you just assign them is a one single entity. Okay, here is the unification or integrated version is Rahul K. Sharma, and so on. Right? And you can basically go in the LinkedIn and the Twitter, see basically whether he has an account and get more information and populate, and then you store that information in the database. So this is what is my single truth, right? And then you map this entity with this entity, with this entity, with this entity. So now we know that this guy is my gold customer, right? So when anyone comes to the mobile phone, now you saw the, okay, this is linked over here, this is a gold customer, you divert that customer to the premium line, and so on, right? So this is a single truth, getting the single truth by integrating the information, right? Same information, the biomedical science. In the biomedical, you have so many genes, the Swissport data, the medical data, the health records, and so on. How to integrate that information to find the patterns of genes and so on, right? The entity based, as I said, so given a relational databases, this is relational table. Given a my some articles or my unstructured information, you extract the information and create the table. So for example, this is a unstructured information, you write the annotators for the name and positions and the country, you just go and populate over here, right? And how it works, basically you parse this one, extract these noun phrases or the part of the speech, you write those annotators for them, pull out those information, and then contextually you relate that information and create the records. And we will see a few examples as we move forward, right? So this is one example here, is that given the raw data, so this is my raw data over here, this is my relational, and this is the raw data, the documents over here. From these documents we extract these entities, then we do the entity matching over here. Then we say, hey, Apple and the Apple Corporation is basically, here is Apple one corporation, and IBM and the IBM Corporation over here. This is my integrated information. Now you analyze the integrated information, which is partially the structured data and partially the unstructured information, right? Now, how do we do this? What are the steps involved over here, right? So given two tables, X and Y, right? Or indeed the X1, right? So what we do, we first look at the steps related to the data cleansing, right? So we say, hey, the GE revenue is 351. There is something messy over here. It cannot be. You go to the outside source and look at basically and figure it out. Hey, this is not 351, it is 35.51, right? So this is the data cleaning information. Then the second is basically, since you are integrating the information, right, my schema should match. So here ID matches with ID, the name, and in another table it is a company name, because these two tables, they are designed by different people, right? There was no coordination. So now you figured it out, hey, name and the CNAME, they are the same one. So either you use the domain knowledge or thesaurus or ontology, or basically do the schema matching algorithm based on the edit distance, right? And look at the data values over here. Once you have done that, then you do the schema merging. And schema merging, basically here you say that, hey, name and the location over here is the same as basically the CNAME, address, and the revenue. And then basically you just get in the output schema is the name, location, and revenue. This is the output one, right? And then once you have done the schema matching and merging, then you do the data matching. That is whether this entity is same over here or not, right? And then you data matching, then you do the data merging, and based on the data mapping that you have defined, you just go and populate the schema, find output schema, right? And this is what the way you are integrating the text and the data, right? By involving basically different steps of the machine learning algorithms that you can apply. Okay. This is another scenario for the public safety one, where you are given basically the structured data, the entities of persons, then you have some text, that is coming from a news or reports or the email or the inspector on the this, and this guy says that I saw Mr. Thapa and Mr. Muhammad, basically they were basically meeting together, and now Mr. Thapa is there basically in my tracking list, and now we correlate that information and we say, hey, Thapa and Mr. Muhammad, one, they are related to each other, right? And then there is another mention of Mr. Dinesh, and now Dinesh is not correlated in this database. Now we say, hey, Dinesh, Mr. Thapa, Muhammad, all these three, they were mentioned in a document. Therefore, there is some kind of relationship between these three entities, and we just go and create the relationship between the Dinesh, Muhammad, and Thapa, right? And by integrating these three entities. We can do the entity enrichment also. So given a, let's say, my chapter, you just go and extract the information, and not only that, you can also enrich. So for example, if it is a learning content, you can basically extract that and figure it out, hey, how difficult this chapter is to read it, right? So readability score, how many concepts are described, are these concepts dispersed one, or they are very much crowded, right? And then you basically compute or these other information, and therefore you can enrich the text document, right? How the search works in the Google, right? So for example, if you type the apple, not only it will give you this, it will give you basically some kind of structured information on your right hand side. So what they have done, they have pre-processed that information, and they know basically the apple, they go basically with some kind of decision tree, okay, over here, and with that, when they found the apple node in the decision tree, with that node they create basically things, okay, what is the stock price as of today, who founded, where is the headquarter, what is the total sales, number of employees, and so on. And that is what information that you saw over here. So this is integration of structured information with the unstructured data. Okay, let me take another very interesting example here, which is data finds data. So you are given number of data repositories. So you are given passport data, driving license data, ration card data, vehicle registration, water, mobile phone, electoral rolls, various kind of data sources are there. Now, but they are basically integrated, right? They need to be integrated. Now we want to, there is a one person that is there in the investigation agency. They want to know about this person. So now there is a person, Jugal Raj. This investigation agency wants to know where does this person lives, right? So, and in their databases, they have various kind of data. So what they have done, they have integrated this information and created a single view of that information, the one that we just discussed. So now they want to know, they want to do full investigation. Who is this Jugal Raj? So now they go and query the database, and they figure out, hey, Jugal Raj basically is from Basant Vihar, right? Is in Delhi. Now they want to know who are the people related to the Jugal Raj, right? Who is associated to him. So now, since that information, now we know from the previous data, from that where does he live, from there we know what is his phone number, we know basically whom he has called, and from that data we know basically that, hey, he is related to the Sangeeta Raj and Prasad Desraj, because he is calling them very often, right? There could be any other one. Now we know who is associated. Now we want to know more about this person. Give me basically more records on him. Then we go and see basically his passport and the immigration data, and we figure it out, hey, this guy visited the Bangladesh in the last 3 months, right? So there is some kind of suspicion over there. So they create some kind of events, the investigation events, right? Now they create a alert that, okay, based on the events that they have created, right, if alert me if anything happens based on the events that we have defined and interest to is happening to this Jugal Raj, right? So now they have kept a tracker. Now a person, a international visitor, basically comes on the immigration into the lands at the airport, and he writes the address of Jugal Raj of Basant Bihar, Delhi. When he writes that, when he goes to the immigration, and that when this guy, basically the immigration officer, writes his address, since we have put the tracker to this guy, now we know basically that, hey, this guy is going to stay in the Jugal Raj's place. So now we associate these two guys, the visitor from Bangladesh and the Jugal Raj, right? We associate these, integrate these two entities. Similarly, basically, you can do this in real-time information integration, right? And this is very, today's, you go to the airlines reservation systems, particularly in the US, right? You will not find any person. They will ask you, okay, let me assist you, right? The system is speaking. Can you speak your name? When you say speak name, can you say your PNR? When you say your PNR, they basically go and track that one. So this is exactly the same thing. As you are speaking, we go in the database, convert the speech to the text to the search, get the data from the database, and integrate that information. Okay? Now, let me take basically a different kind of scenario. So far, all the scenarios that we saw, we integrated the information and kept it in a single database. In these next two scenarios, you will see that if my data source is autonomous and they are owned by the business, and business don't want to basically, integrate the information, then the natural questions that arises, can we still integrate the information based on the user query? Okay, so let's say basically here a person, so you have a two data sources, you have basically the information about the stocks, you have a company information, company, what business they are in, and so on. So that is all relational databases. Then you have a analyst report, recommendations of those stocks, what are the financial position of each of those stocks, and so on. So you have various kinds of reports, emails, recommendations, all those things in the unstructured information. So now user give a query that give me the three companies that have been the most volatile in the Bombay Stock Exchange, right? So, right, or New York Stock Exchange, because the example that I saw. So this guy basically gives a query, and the query goes to the database, and the database returns basically that, hey, the database basically returns that IBM, Oracle, and Microsoft, these are the three most volatile companies in the stock market. Now, what this score system does, score would like to basically discover the intent of the user. When the user is giving a query, give me the three most volatile companies, right, in the stock exchange. Now the intent here is not only to give these three most volatile companies, but also to tell why these three companies have been the most volatile. And to answer the why kind of questions, we first need to look at, is there some common things between these three companies? Is there any affinity? Because all companies are doing well, right? These three companies are not doing well, right? So, right. So, what has been the common? Is there any affinity, right? So, discovering the intent of the user from the user's query is the one important aspect of score system. So what this does basically, that system, that okay, these are the three most volatile companies, but then system goes, okay, these are the companies, the query is hitting this particular table, then each of the stocks is belong to particular sector, that sector basically belong to a particular industry, and then it figures out, okay, IBM, Oracle, and Microsoft, these are the three most volatile companies in the New York Exchange one, and they are in the database and the software engineering, and these are the large cap companies. So you get this additional context, the context basically from the query result, and by looking at the querying table and the surrounding tables. Okay, now use these context as a keywords, and then give these keywords to the search engine, get all the documents, and then correlate the documents with the data. So this is the data, this is the document. So now user basically gets not only the data, but also the documents that describes why these three companies have been the most volatile. So these fetches the document basically that there was a Gartner or Forrester report that the businesses of the database are going on the cloud, they are basically going this, then therefore basically the revenues went down, and therefore the stocks basically really tumbles, right? So that is what basically that integrating the, it is a soft integration, and the integration, the document fetching depends on what is the context, right? If this context would have been, for example, IBM, Micron, and Intel, then the context will be basically is integrated chips and hardware. The context will be different, right? So depending on what is the query result, so look at the query result, go in the surrounding tables, because many queries basically are joining with the foreign key and the primary key. Go over there, look at that information, fetch that information, and give that into the in a search engine to get the documents related to the context, and then you integrate integrate basically the data and the text. So in this is a new way to integrate the information without basically knowing the schema or the data model for the underlying databases. Let each data source run the way they are running, right? And then you fetch the information based on the extraction. Okay. So let's take another example, right? So let's say the bank is seeing basically that a lot of customers are canceling the credit cards. So now they want to analyze who are these customers. Is there any something common between these customers who are canceling the credit cards, and why they are canceling the credit cards, right? So my analyst, a business analyst, writes a query that give all customers. So he writes basically that select star the customer name and this, write all that information from credit card table where basically the time is less than last 3 months. Okay, and the status, credit card status equal to cancelled. So this query goes into the database, and then the score basically returns, or the database returns basically, hey, these are the 5,000 customers who have cancelled the credit cards the last 3 months. Now what the score does, score basically analyze this information, and this basically goes over here, right? But the score, what this does basically analyze this information and says, okay, that the people who are canceling the credit cards, most of them, they are holding silver card, and they are coming from Mumbai area or from Calcutta area, right? And they have written the number of complaints more than 2 times. And their sentiments from the complaints are very unhappy. And they are basically very valuable customers of band 3 and band 4. So you extract all this information. Now, what will be the bank, next step? That they would like to know that who are the other clients who have the similar kind of feature, but they have not yet canceled the credit cards. So now they go in the database and fetch that in those things having these features and get this additional customer. Hey, these are the 7,000 customers who are falling in this category. They have written the complaints. They are coming from Calcutta or Mumbai area. They are holding the silver card and they are very unhappy because their unhappiness is reflecting in the complaints, and they are the band 3 and band 4 customers. So now the business decision makers basically can take the steps to basically contact these people and solve their problem so that they can prevent the attrition, right? So this is one example, right? There's one, right? The other example, so in the previous one, we were going from structured data to unstructured. Now we want to go from unstructured to structured, right? So you have a database, structured database, you have a unstructured. Somebody has written a complaint. I'm John Smith. I bought a Sony DVD player from JK Electronics, and I would like to refund this one. I'm not happy. I would like to refund this DVD player. So now the person who is handling this would like to know who is this person and whether is he eligible to return the product or not, right? So what he will do, he will go and search the database, look at basically the guy, John Smith, who has bought the Sony DVD player. So when he goes and search for the John Smith, right, and the DVD player, we say, hey, there are 50 John Smiths who bought the DVD player. Then he goes basically look at how many of them, JK Electronics and Sony, and then he figured it out, hey, this is the John Smith, right? And he find the transactions, and then he finds all the contacts, and then he say, hey, this John Smith who bought this DVD player, he basically paid the money through MX card, and he bought this item under this promotional scheme 1236, and under this promotional scheme the item is non-refundable, right? So then he can reply, or you can automate this process, reply automatically, no, you bought this product under this promotional scheme, and under this promotional scheme item is non-refundable, right? So this is another kind of information integration where you are going from unstructured data to structured data, right? So there are several really interesting challenges over here, right? The challenges is managing the different platforms and therefore the data. As you saw in the information integration platform, the data is stored in various repository in various formats, right? In various different ways. So how to curate that information, how to define the quality around this data so that we can answer the questions, right? And that, yes, this is a good quality of data. Other is that since these schemas, they are heterogeneous data sources, therefore the schema is heterogeneity, how we can define this schema mapping, data mapping, and the information discoveries, and so on. And all the vendors, what they are doing, they're automating this data curation process. And they are applying the AI or the machine learning in the data curation. So as my data comes in, they understand the data. What is this data? Where this data can be used for? Where this data can be linked one? So they create all that metadata, right? So they are applying the data curation life cycle. They are applying the AI the ML basically as early as possible, so that they can understand the data, they can reason from that data, they can learn from that data. If they need to provide the feedback, right, for understanding this data in a better way, they do that. So AI is playing, so this is called AI for data, right? And that is exactly basically AI for the information integration cycle, right? There are many technologies that are required, and what we will discuss is machine learning based entity discovery and the extraction and completion of the data matching and data quality, right? And that is the key aspect, and we are going to spend next slide, next session only on basically on the different ML methods, right, for data matching and the entity matching. So with this, I'll stop here, right? And in the next session, I will cover the second and the third part. I'll go a little bit faster, right? Because I wanted to give you, motivate you that why this problem is important. And let's take the questions that you
Yes.
have now.
So,
Yes, Vikram.
yes. So primarily, we have just got one question from the participant, and said, I mean, this may be related to his specific research areas. Question is, how named entity extraction is helpful in internet search? So,
So all the internet search, the Google, right, or any search engine is basically based on the entity named search.
yes,
So as I said, they pre-process billions of documents. So the example I gave you, the Apple, right? So
yes,
when you search the Apple, or when you said, say, basically, let's say Jordan, will it show you the Jordan as a country first or the Michael Jordan as a first? And they have learned all these things from the previous data, and based on that, basically they rank that information. They do the annotation of those entity a priori, and therefore
right,
basically on the right hand side they display you all the structured data, that is all the major entities related to the your search keywords.
right, sir. So actually, I have explored a few of the part. I mean, we have some kind of familiarity. Like in the initial work of my PhD, I have explored this specific domain called data space. So on that aspect, it was like it is the primary task to integrate sources to generate the similarity between the different sources and their semantics. So now, I mean, with this talk, with this session, I have gained a lot of information relating to the fact that now data values can be also utilized for that purpose. So we have got just two questions.
Yeah.
One of the participant, Dr. Mrityunjay Singh, is raising question: when we perform the data transformation, in that case, it may possible the data uncertainty. So how we handle this? How we can handle this, sir?
This is a very good question, and definitely there is a uncertainty.
Yes.
Uncertainty in many terms. Uncertainty in terms of the trust, right? Uncertainty in terms of the value is missing. Uncertainty, basically the value at that point of time is not known. So here basically you bring the domain experts, you code their knowledge, right, and form that as a rule. So for example, if you know that this information is coming through tweet, probably you may not trust it, right? But if the handle is basically very trustworthy of that tweet, then you will assign, okay, I trust this information with some confidence, right? So uncertainty plays, and there are many algorithms work, lots of work, that how to integrate the information in the case of uncertain data, right? And here, as I said, initially the domain experts need to provide some knowledge that what trust they can put it in the system, right? And remove some of the ambiguities that we have. So the example that you saw the last time, in the last slide, John Smith buying DVD player from JK Electronics, right? Now, if you say basically, let's say JK Electronics, The JK Electronics could be, your company name, or it could be a store. But when you now, so JK store is coming in both, is a company name as well as the store name. But when you look at basically, DVD player for John Smith, now you say, okay, you prune it down. Hey, in this case, the JK Electronics is not a company, it is a store name. Because in the context of other information, so some of the uncertainty can be removed. Uncertainty basically can be removed with respect to the contextual information that is given in that document with that entity.
Right.
Okay.
So yes, so there is another question. Yeah, I think we have addressed this answer. Yes, sir.
I can't really say the regional languages. That's a very
Yes,
good question, right? I can say that when I was in IBM, some of my colleagues were working on doing this English, right? And even in the SMS data, right? And it was really, really very, very difficult. And I'm sure some of the, like, you can do the dictionary approach. So if you have a dictionary, basically you can convert that regional language document into an English language, and then you do the entity extractions. I think that could be one way to do that. How will you identify structured data? Come on, how will you identify the structured data? And structured data that has some structure, right? And unstructured, which is basically doesn't have any structure, it is stored in the file systems, right, and so on. Some part of the unstructured information, short unstructured information, can be there in your address, in your structured data. So for example, when you say varchar, right, in varchar you typically write just some text, right, of that, or even the address, right, like Indian addresses are highly, they have a structure but also not a structure. You write behind my house, one oblique this, behind Hanuman Mandir. You're basically, some family members writes basically opposite to that park, right? So you bring some kind of very short kind of unstructured data, though address is a structure, but you can bring that, and you can see basically whether the information has structure or not. Okay. Are there any complements to, are they complete? Yes, of course. The structured and unstructured data, they complement to each other if they belong to the same entity. So as I said, you write an email to the bank about why you have charged 250 rupees for a quarterly balance, right? Because you have an entity you are their customer, right? So they are complement to each other, and one can look at that. Can we split structured data? Structured data can be split to the unstructured data and vice versa? Vice versa is yes. So doing all these annotations, extracting the information, the whole objective of there is to structurify the unstructured data, right? So given a document that has your name, let's say your resume is unstructured information, and resume has your name, your qualification, your experience, and various other things. We can write the annotators, extract the names, extract the qualification, extract the affiliation, extract basically other things, and you structurify and convert that into a structured database.
Right.
Can unstructured data can be converted easily to it is a complex process, not easily. As I said, the example just I gave you, the resume database, right? Extracting even the names, because some people writing the resume name in their middle of in the first line. Some basically writes basically, in somewhere in the third line or the second line. Somewhere saying name, column, then actual name, right? So you need to look at basically, you need to write the rules if it is a rule-based one, or you can write, if you have all possible names of Indians, let's say for Indians, right? Then you can have a dictionary, you extract every noun phrase or part of the speech, and then you look up in the dictionary. If it is found in the name dictionary, then you say it's a name one. right? Or similarly, in the enterprise, you have a client name, you just look at the client name. But typically, basically, you write the regular expressions, right? That, for example, if there are two consecutive words and each first character starts in the capital, and these two consecutive words, basically two or three or four, if they basically are coming in the first 5 lines of a resume, it is likely to be one. And you write a name, and then you learn from there, and then basically tweak these things. So it is a complex process even for a simple entity names. But named entity annotator, product entity annotators, organization entity annotators, date of birth entity annotators, these are basically, very widely available, and you can check, basically apply them depending on what unstructured data corpus that you have over here. Okay, any other questions?
Yeah, so I think we have done with the posted question. If any participant wants to, directly interact, he or may, enable the audio and just raise the question, or maybe, yeah. So we can wait for a few seconds. Otherwise, we will conclude this session and we'll proceed for the break, and after that, we will resume for the next session.
Sure.
Yeah. So we are getting now different requests. So yeah, so recordings of the sessions are, we are, as per the IICT policy also, we are uploading all these session recordings into the YouTube. So that's there, sir. And I will be sharing the links for those YouTube channel. So I think we can stop here, sir. Right, sir?
Okay. Yeah. Thank you so
And
much.
we'll resume. Yes.